Hey there, hi there, ho there. Welcome back. This is Unit 3 on earthquakes. Starting off on a couple of websites. These are also linked in the PowerPoint themselves, but let me just show you. So the USGS, the U.S. Geological Survey, is the main geology body of the United States. They do host a website with a bunch of information, including on earthquakes. Kind of a cool website. You can go here and see some of the latest earthquakes that have occurred, not only in the United States, but around the globe as well. So you can see within the past day. So these are all earthquakes that have a magnitude of 2.5 or more just in the past day. Around the world, there's been 25, and we can see there's 1, 2, 3, 4, 5 in the United States. Got one right up here in Nevada. Let's see, magnitude 3.0. All right. What that number means more in a little bit. But in any case, there's a lot of information from the USGS on earthquakes. And same with Arizona. The Arizona Geological Survey, the AZGS, also has a bunch of earthquakes on Arizona, or a bunch of information on earthquakes in Arizona. Reason being, we get earthquakes in Arizona. They're not the big, huge, giant ones that we see and hear about on the news and movies and such, but we still get them every once in a while. So let's go ahead and get this party started. All right, so here we are, Unit 3 on earthquakes. Here are those websites if you're interested in checking out some information. There's also some great apps too, some fun little apps that you can download and get information on earthquakes and alerts when earthquakes occur. So let's get to some of the basics as it pertains to earthquakes. So movement of plates. All right, so as the tectonic plates move around, driven by mantle convection, which is driven by the heat inside the Earth from Earth's formation and radioactive decay. So driving, again, mantle convection, moving the plates around, going in reverse. So it's those movements within the crust which cause rocks to deform. All right, so especially at, for example, here we're looking at a convergent boundary. So what we get, one plate is being subducted, and as it does, it's kind of pulling the edge of that overlying plate kind of down, deforms it. You start to store up energy. It's starting to store up energy, kind of like, if I'm taking this and I'm bending it, I'm storing energy. And if I release that stress, that energy is released. Okay. Same thing in the Earth. It's hard to imagine, but rocks do bend, and they do break. When you're talking large tectonic plates, there's a lot of force driving that. So when the stress of kind of that interaction between plates or rocks or whatever it may be finally exceeds the strength of the rock fractures, it slips, or there's some sort of snap back of the plate, some sort of rebound along a fault. All of that stored energy is suddenly released. That stored energy being released, that's what you feel in the earthquake. That energy being released, rippling through the earth, quaking the ground. Excuse me. So, where an earthquake occurs is along a fault. A fault, which we'll look at in a little bit, is any place where there's some breakage and movement of rock material. That can be at or near a boundary, and it can be away from a boundary. But as it pertains to the earthquake, where the initial point of rupture is, where that the earthquake starts, is called the focus. That's the point of initial breaking or rupturing within the earth. That's where the earthquake occurs, at the focus of the earthquake. The term epicenter, which you may have heard on the news or on movies and such, that is the place on the surface directly above where the focus is, directly above where the earthquake occurred. So the earthquake occurs at the focus at some depth, 10, 20, 30, 50, 100 miles below the surface, whatever it may be. But we call the point direct on the surface of the earth, directly above the focus. We call that the epicenter. Typically, the epicenter, at least on the surface, is the area where you get the most energy, the most destruction, the most damage at the epicenter. And it gets less and less and less the further you get away from the epicenter. So again, earthquakes occur along fault lines. Again, a fault is where there's any break and movement of rock material at or near boundaries, or sometimes away from boundaries. It doesn't have to be just a convergent boundary like I showed you in the example. So when we're looking at these faults, these ancient faults, when they break and move, If it's just breakage of the rock or plate, that's no earthquake. You have to have breakage and movement. That's what's going to release that energy. So as far as faults are concerned, a geologist will consider a fault to be an active fault if it has moved within the past 10,000 years. So if there's a fault, some break and movement, whether these faults are only a few miles long or hundreds of miles long, if there's been some sort of activity in the past 10,000 years, geologists consider that fault active, meaning there could potentially still be earthquakes. Faults that have not moved in the past 2 million years are generally classified as inactive. They're probably not going to move anymore. Now, in between those two, it's kind of like, well, maybe. That we would consider those to be dormant. So they could, but they also might not either. So when we're talking about geology and geologic time, we're talking, again, remember, 4.54 billion years of Earth. So 10,000 years, even 2 million years, that's a blink of an eye as far as the Earth is concerned. So, where do earthquakes occur? Living here in Arizona, in the U.S., based on movies and such, you can probably understand quite easily where, at least around us, earthquakes occur. California is what we think of. Well, when we look at this map, the earthquakes are these kind of yellow orangish dots. These red lines indicate plate boundaries. So look at where the majority of these orange dots are. They're pretty much close to, or if not right on, the plate boundaries. All right. Every once in a while, you'll get some random kind of earthquakes away from a plate boundary. You can see some here, maybe some up here, but not too much. Maybe a little over here. So for the most part, where you're going to find earthquakes is right along plate boundaries. As plates are jostling and interacting and crashing in or pulling away or sliding past one another, stuff's going to break and move. It's going to happen. So, most earthquakes occur along plate boundaries. Now, that's in contrast to something called intra-plate earthquakes, which are infrequent. Intraplate earthquakes happen in the middle of a plate, not near or on a plate boundary. Earthquakes will occur along some plane of weakness in the crust, again known as a fault. These are very common along plate boundaries. Or if you're looking at ancient faults, maybe one where there once was a plate boundary or some sort of major tectonic activity. But again, however, breaks and movement of plates can occur in the middle of plates themselves, causing faults far from any boundaries. Again, those are called intraplate earthquakes. But again, so these orange dots indicate earthquakes, and you can see the vast majority of them are near or on a plate boundary. Every once in a while, you'll get some kind of rogue ones, kind of in the middle of a particular plate. Old faults, old breakage, there's still some movement there that can occur. All right, so earthquakes don't only happen on boundaries, but that's where most earthquakes occur. 90+% of all earthquakes occur at or near a plate boundary. So if you live at or near a plate boundary, like the folks in California, well, that's why you're going to experience so many darn earthquakes. There you go. So in Arizona, we still have our fair share of earthquakes, as mentioned. All these blue lines indicate faults that there has been some sort of movement over the past 10,000 years. So we do have little micro faults, little breaks in the plate. A lot of that is due in part to how Arizona was formed, the tectonic activity kind of pulling on Arizona, breaking things. So there are small faults throughout Arizona. And the green dots represent historical earthquakes, I believe of a magnitude 2.0 or higher. I believe. I could be wrong. So not all earthquakes are plotted. There's small earthquakes almost everywhere, every day. So of a certain range, that's what you see here in Arizona. All right. So we do get them. There is a place in Arizona considered the Arizona seismic belt. The vast majority, not all, all right, but the vast majority of faults and earthquakes kind of fall in this line, and you can see definitely the vast majority of faults and earthquakes in general are kind of northern Arizona, kind of northwestern Arizona, Flagstaff, Grand Canyon area. That's where the lion's share of faults and earthquakes occur. I mean, we get have historically earthquakes elsewhere and little faults elsewhere. Around Phoenix, not too much, but it does occur. But again, northern Arizona is where you're going to find most of those earthquakes. You got me? Northern Arizona, and that's the within the Arizona seismic belt. Maybe it's somehow tied to this kind of rugged terrain you see. There's also a lot of volcanic activity in Flagstaff. More on that in a later unit. But kind of in this rugged area is where we tend to see the most faults and activity, earthquake activity in Arizona. Sorry, I had to do a quick pause there. So what about Arizona? What are some of the more major and recent earthquakes in Arizona? Let's take a gander, shall we? So, you can't see it because I'm blocking it, but down here, the Sonoran earthquake of 1887. So just outside the border, just south of Douglas, it was a magnitude 7.6 earthquake, which is rather large. More on that number in another section. So a rather large earthquake, killed 60 people, felt throughout the Southwest, including Tucson, Yuma, Phoenix, all the way up into Prescott and Albuquerque and over into Texas as well. So that was kind of a bigger one, a little bit older though. In Flagstaff, 1906, 1910, 1912, kind of a series of 3 moderate earthquakes rattled Arizona, felt throughout northern Arizona. 1976, we have in Prescott, a 5.0 earthquake. 1993, several earthquakes in the kind of the south rim of the Grand Canyon area. Imagine kind of being at the Grand Canyon or hiking down in it and have feeling the ground tremble. That'd be kind of scary. And then some of the most recent felt events, not necessarily big at all, destructive, but definitely felt. So 2005 in the Holbrook area, 2014 over on the east side of Arizona near Duncan, and then in 2014, the Black Canyon City definitely felt in Phoenix. So that wasn't too long ago, 6 years ago. All right, so more on those numbers, what they mean, but again, we do get our fair share of earthquakes here in Arizona. All right, so we're going to pause there. Before we do, let me give you the first part of the super secret code. It is the number 6. You got me? The number 6. One more time, the number 6. So we'll pause here, and when we come back, we'll talk about those faults, what I had mentioned earlier. See you back here in just a minute.